Okay, so you're welcome again to Kanga Academy Tutors. So today we're going to go through how to solve this leveling question. We're going to go through how to solve this leveling question. So you can see you're having some columns here. This is not the usual leveling. I think this one is combining both the height of collimation method and the rise and fall method. So you can see the HC here means height of collimation, then the RF here means rise and fall. Okay, so we're going to use the two methods of leveling calculations at the same time to solve this problem. And at the end of the lesson, you know how to compete for cut and fall. Okay, so this table, before you can fill this table, you should be able to have your basic information. So your basic information will be the backside values, the interside values, and the foresight values. And all these are in feet. The FT means feet. So the BS means backside, the IS means interside, the FS means foresight. The HC means height of collimation. The the RF means rise and fall. The RL means so the RF means rise and fall. The RL means reduced level, and the FL means finished level. And this one means cut and fill, and this one is the label to indicate whether the place was cut or fill. And these are the changes, that are the distances from individual positions of the levels. And these are the point description. So now you can see here I've used colors to depict the cross or the level traverse legs. So from this back side to this foresight is the first traverse leg. From this back side to this foresight is the second traverse, and from the blue here and to the last blue here, that's the back side to the foresight here, is the third traverse. Okay, so we're going to learn how to compute all this. So when you look at the question here, some of the information from the table was filled already. So they gave you the rise and fall here, they gave you the reduced level here, they gave you the finished level here. So we are going to compute it from scratch. Okay, we are going to compute it from scratch. So they gave us some values here, the finished level here, and here to they give us the height of collimation, they gave us the rise and fall value, they gave us the finished level, the reduced level, and the finished level here. So we are going to compute everything from scratch. We are going to compute everything from scratch. So that's why here I'm not having those values inside. They're going to know how they got all these values. So always, before you can get the cut and fill values, the finished levels of the various sections should be given to you. So before you be able to know the finished level of an area, you should know the reduced level, or the designer has to give you the finished level or the various areas. So you are not going to compute the finished levels. You are not going to compute the finished levels. You are not going to compute the finished level. So when the finished level of a particular chainage is being given to you, that's where you'll be asked to find the cut and fill of that section. That's where you'll be asked to find the cut and fill of that. Okay, so first we have to compute the initial values here. So whenever you are working with a height of collimation method, when you get your backside and you have your initial reduced level, you have to get the height of collimation of the instrument you're going to work with. So now before you can compute the height of collimation, you have to know your backside, you have to know your initial reduced level. So now our initial reduced level here is 97.55, as you can see in the question, 97.55. feet. So now let's compute our height of collimation. So I'm using Excel, so it will be 97.55, then 97.55 plus my backside, and this will give me my height of collimation. To give me my height of collimation of the change zero, or at the position of the instrument I'm working with. So that's the initial height I'm working with. So with this traverse, I'm working at this what, at this height of the what, the instrument, or at this height of what, collimation. Okay, now how to find the rise and fall at this section? How to find the rise and fall at this section? Okay, so now our initial reduced level here is what, 97.55. So just have to write at 97.55. That is what our initial reduced level at what point, what, 0. Now I have to compute for the rise and fall at this place. So this is my horse backside, this is my what, in my intercept. So always subtract the last one from the first one. You subtract this one from this. So this is the column for the rise and fall. So it will be equals to, so equal to, so no, it's this place. So equal to 6 minus 3.03. Okay, so this is my what, rise and fall at this place, and I have to get the rise and fall at this place. So this one is a positive value, meaning that it's what, it's a rise. Now let me compute this one. So equals to this minus this. Okay, and this one is minus 1.88, meaning that this one is a 4. So you can see in the equation here to go the same thing, minus 1.88. So that's what, a 4. Okay, so now I'm done with this what, first traverse. I'm done with this first traverse. Now for me to compute the rise and fall here, meaning that I'm moving to the next traverse leg. So I'm going to subtract this one from this. So here will be equals to 3.81 minus 4.66. Okay. And this one is also a 4. Now for me to compute this one, I have to subtract 5.16 from 4.66. So here will be equals to 4.66 minus 5.16. Okay. It's also a rise. It's a 4 because it's what, a minus. So here will be equals to 5.16 minus 5.16. Yeah. Okay, sorry for this. So we subtracted. So here, because so here was subtracted this one from this. Then you got here. So now here will be this one. So equals to this one minus this. Okay. Then here too will be the last traverse for this one. So equals to this one minus this. Okay. So now we are done with this traverse too. We're done with this traverse. Now moving on to the last traverse. So here will be equals to, so we take the back side, subtract our interside, back side minus interside. So this is our rise and fall for this change. When you come here, equals to, so we take this minus this. Okay, then this one will be equals to the previous minus this succeeding one. Then the last one will be equal to, so this one minus this. Okay, so now we are done with our rise and fall. So that's how you compute the rise and fall. Now for us to get our height of collimation, So now this is our height of collimation. So you have to compute the height of collimation at these places. Okay. And before I can get my height of collimation at these columns, I should be able to get my reduced levels at these columns. So now we're going to compute our reduced levels using the rise and fall values we have right now. So here will be, so it'll be equals to, now we're going to add all these values here to the reduced level here. So it will be this, then plus this one, and this one. So meaning that this reduced level 100.63 is the reduced level at change 10. At change 10. So the 100.63 here is the reduced level for change 10. So now you're going to compute the reduced level for change 20. So here will be, so equals to, so I will take this one, then plus this one. So it will be plus minus, because here is what a negative value, so plus minus. Then I'll compute. So you will get 98.75. So you can see in the question here that they also had 98.75 as their reduced level for change 20. So now you're going to compute the reduced level for change 30. So now we're going to add this one to this. So it will be equals to, so now 98.75 plus minus 0.85. And this one will give me the reduced level for this place. So here too will be the same scenario. So equals to, so I'll take this one, then plus this one. Then here too will be equals to, so I'll take previous one plus the 4 at this place. Here too will be the same. So I'll take this one plus this one. Here too will be equals to 96.06 plus 1.35. Then here too 97.45 plus 0.83. Then here too will be 98.24 plus 0. Minus 0.42. Then here too will be 97.82 plus minus 1.01. So you can see that here they also had 97.41. 97.41. We also had the same thing, 97.41. So this confirms that our use levels here are correct. Our use levels here are correct. So now we are done with our use levels here. Now we have to compute our height of collimation. How to compute our height of collimation? So always the height of collimation is the backside plus the reduced level. That will give you the what? The height of collimation. So wherever you did a change of station, so you can see that this one is one change of station. This was the starting station. So we are having the height of collimation at this place. This was the second starting station. This is where we set our new station. And the backside there is 3.81. So for meaning that we have to get the height of collimation when we set the instrument at the second station. So before you can get the height of collimation at this place, you have to add the backside there plus the reduced level at that station. So the reduced level at that station is 98.75. Now the backside at that station is what, 3.81. Then, so for us to get the height of collimation at change 20, you have to know the backside and you know the reduced level at that change. So we are having the reduced level of 98.75 and the backside of 3.81. So 98.75 plus 3.81. That will give us 102.56. So that's the height of collimation at that particular change. So if you check in the question, you're having the same height of collimation of 102.56. So now let's compute the height of collimation for the other traverse legs. So let's compute the height of collimation at this place. So you can see that here was the third place we set our instrument. So you're having the backside here, we're having the reduced level here. So we have to compute the height of collimation at this particular area. So it'll be equal to the reduced level here plus the backside here. That will give us the height of collimation at that particular change of 60. So you can see in the question that we are having the same thing. We are having a height of collimation of 101.91, and the one computed here is also 101.91. So now we are done with the height of collimation. So it's left for us to determine where there should be a cut and where there should be a fill. So in the question, they gave us two particular finish levels at chainage 20 and at chainage 70. So we can see that before you be able to compete for the cut and fill, you should get the finish level at that particular chainage. So here we don't know the finish level here. Here too we don't know. And this particular cells too we don't know the finish levels. But at chainage 20 and 70 we know the finish levels. So we should be able to compete the other four. So for you to understand how the cut and fill is being done, I'm going to use this graph to show you how the cut and fill is being done. So let's look at this graph. So let's say you want to get a flat surface of which the elevation there is, let's say 0. So we are using the middle point here as our 0. And since for leveling you're considering the height above or below the surface, you want to attain a reduced level of force less 0. Meaning that if the so let me draw something here so that you understand the cut and fill. So let's say this is our terrain. This is how the terrain looks like. So you're having our gun here. So you can see here is below the what? The 0. So meaning that if you want to get the 0 here or get this flat land here, you have to fill here. How to fill this particular height. That's what? Minus 1. And if you want to get the 0 here or get a flat level here, you have to be able to cut this hill here for you to able to obtain your level or flat level. So therefore whenever you subtract, so let's say that our first level here is or level here is 70 and the elevation here is, and let's say the reduced level here is 75 and the finished level here is 70 and the reduced level here is, let's say, 69. So now we know the finish level. So we want to determine the cut and fill of this particular place or this particular challenge. And let's say this particular challenge, the challenge is challenge 50. Now the finish level at this challenge is 70. We are having the higher reduced level here to be 75 and here to be 69. So what you have to do is that you have to subtract the finish level from the reduced levels. So when you subtract, here is 75, when you subtract 70 from 75, you will get 5. So meaning that from this 0 or from this level to this level, you're having a fill of or a cut of 5 feet you have to cut. And here is 69, here is 70. When you subtract 70 from 69, you get -1. So meaning that before you can get the level here, you have to fill a height of 1 feet. So meaning that it will be -1. So that means that minus means that you have to fill a place, and plus means that you have to cut a place. So now for you to be able to compute the cut and fill of the particular changes of which the finished levels are given to you, you have to subtract the finished level from the reduced level of those changes. So now you can see here at change 20, they gave out the finished level of 98.75. Now, if you subtract 98.75 from 98.75, you get a cut and fill of 0. So meaning that at this place, there won't be any fill, there won't be any cut. So no fill and cut. There won't be any fill and cut. When you come here to here at change 70, they gave out the finished level of 70, 97.41, and the GC level of 97.41. So when you subtract, you will get 0. So here too there won't be, so there will be no fill and cut. How will you get it? So for leveling, when you run your reduced level, you should be able to get the same close reduced level given to you. So you can see here they give us a close reduced level of what? 97.91. So meaning that here too we should have got 97.91, but here is given at 96.81, meaning that there should be a correction we have to do. So you have to do a correction or adjustment. So either correction or adjustment, they are all the same. They are all the same. So now let's add some columns to it so that I will show you how you'll be able to compute for the corrections or the adjustment. So let me add one column here. Okay, so here will be our correction or adjustment. Our correction or adjustment. Okay, so now this was when we started our release level. So the correction, you won't add some of the correction here. So the correction here or adjustment here will be 0. Now you have to find the error difference. So the error difference will be the observed minus the computed. So let me delete this one. So now the observed one, so the error, so here will be equals to, so the observed one is the one we computed on the floor, that is 96.81. Then minus the computed, the one that has been already computed, that is 97.91. So 97.91. Okay, and that one give us minus 1.1. So minus 1.1 is the error between our benchmarks, or the error we had when we were doing the leveling calculations, or when we were doing the leveling. So now you have to adjust all the levels using this error. Now you have to know the number of traverse legs or traverse you did. So you have one traverse here, one, the second traverse here, 2, the third traverse here, 3. So what you have to do is you have to divide this one by 3. So now you're going to complete our correction. Now when the error is negative, the correction is positive. So here instead of 1.1, the correction will be instead of minus 1.1, the correction will be plus 1.1. So our correction. So it will be plus 1.1. So 1.1 at a positive 1.1. So we have to adjust all the values here. And since we're having three traverses, so from one back side to the last four sides of that traverse is one complete traverse. Here from the last to the fourth side is one another complete traverse. From the last to the first to the last is the third complete traverse. So I've used the colors to represent them. So now let's divide this one by 3. So equals to 1.1 divided by 3. So we got this value. So this value is our is the so this value here is the error for the individual regis levels. So now I have to add them. So let me compare this. So I'll start with my first change. So here you can see that the regis level here is 75.55. That is the same as this one. So now we apply those corrections to this one. So we start from this one. So now we have to add it. So here will be 0.06. Then here too will be the same value. So this one and this one. Now we are done with the first traverse. Now before you to start with this one, you have to multiply this one by 2. So now I'll multiply this by 2. So now this is the value for this, because we are starting with the second traverse. So I have to add this one here. I have to add this one here. And here too is the same. So we add it till this traverse is also complete up to the last 4 sides. So we are done with this one. Then here too will be the same individual value, the first one times 3. So equals to this times 3. So 1.1. Okay. So here 1.1 we add it. Then this one will be up to the last one. You can see that here we're having the 1.1. So now we've added the errors. Now let's try and add another column for the corrected reduced levels. So this one will be the corrected reduced levels. So we'll be adding this one to this ones. So equals to this one plus this. Okay. So let me run it to this one. Okay, so you can see this is our corrected this level. So just add this one plus 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 this. So we add them till we get. So you can see that now our last reduced level here the same as this one. Okay, so with the addition of the errors, we start from the first one, the last one, but here it should be the same. So that's why we added 0 here. So when you start from this one, you have to end it at the last 4 sides. That will be the first set of error. The next one will be with the start with this one, then you end it to the last 4 sides. That will be the last set of these errors. Then here start from here, then we add it to the last 4 sides. So this is it. So this is how the corrections are being done. So now you can be able to cover how the height of collimation is done, the rise and fall, how it is done, how to compute for the reduced levels, how to adjust the reduced levels to get the corrected ones, how to compute the rise and fall. Then these are the labels. So as a check, so you can see in the question, so we have to check. So as a check, the sum of the back sides should be the same as the sum of the four sides. The sum of the rise should be the same as the sum of the fall. So we can do that as a check. So now let's go ahead and check or do our check. So I will do for the first. You can also try with the next. So now it's saying that the sum of the back sides minus the sum of the four sides should be equal to the sum of the rise minus the sum of the fall. So that let's sum all the back sides. So here will be equal to sum. So I'll sum here. So this is the value for my back side. Then my first side equals to sum to here to here. Okay, now let me find the difference. The difference will be this one, back side minus front side. So I've got minus 0.74 and the difference between the back side and the front side. Now for the rise and fall equals to, so sum, since they are all together, choose all from here to here. So you can see I'm having the same difference, minus 0.74, then minus 0.74. So meaning that that's one check. You're done with the first check. Okay, so this is the solution for this level question. Condemn me for any further explanation. Thank you.